Hello students, how are you all? So I'm Dr. Jayashree from Mlritm, Assistant Professor in Data Science Department. So in the last class we have started the series of DA subject and we have learned in the previous sessions regarding the Prim's algorithm, right? So in this today's session we are going to learn about the disjoint sets. Okay. So what do you mean by the disjoint sets? Here, in the discrete mathematics, we have learned from the childhood all onwards, we are learning about the discrete disjoint sets. So, what is a set? A set is a collection of elements, right? It's a collection of elements where we are taking off the two sets, like set 1 equals to 1 comma 2 comma 3 and S2 equals to 4 comma 5 comma 6. So this is one set S1 set and this is a S2 set 4 5 6. All right. So when we are combining of all this intersection of S2, we are going to get is what? Pi, because no two elements are same. All right, where no common element in the S1 and S2 element. So that's why we are taking as what? Intersection. All right. So in this set, in this discrete mathematics, we are going to frame in the form of a tree. All right. How a tree structure will be? A tree, parent node will have the left subtree and the right subtree. All right. This is a root node. This is a root node, or we can also call it as what? Parent node. All right. And this is a tree structure format. Left tree and right side tree. All right. So now here a disjoint set is a structure and we are going to be called it as a set collection of elements, and where we are taking off the elements in the form of any two sets, that is S1 1 2 3 and S2 4 5 6, where no common elements that we are taking. So you are going to get the answer as S1 intersection S2 equals to what? Pi. All right. And we are going to frame in this today's disjoint sets topic is like tree structure format. From this tree structure format itself, we are going to find the operations of this disjoint sets. All right. So in this disjoint sets, we have the operations where we are going to have. Why? Because we are dealing with the DA. So the design and analysis of algorithms, where we need to design the part, we need to analyze the part, and at last we have like algorithms. Each and every topic we have an algorithm. From that algorithm steps only we are going to frame all the next part. All right. So what we are taking is that now we have like 4 different types of operations here. All right. So what are the 4 different types of operations in this disjoint sets? The first one is like simple union. What is that? Simple union. The first one is simple union. Second one is simple find. Third one, weighted union. And fourth one, collapsing find. So these are the 4 disjoint set operations which are very important for your academic also. And we need to write all these 4 different types of operations for the disjoint sets. The first one is simple union, and next one is simple find, and next one is weighted union, and next one is collapsing find. So as the name implies, that simple union, we need to find out the union operation. Union operation means a combining of the 2 elements, all right, and making as a tree structure form. From the tree structure format, we have some set of rules and regulations are to be followed, and based upon that rules and regulations, we need to continue the process. All right, what are the rules and regulations for this simple find? Now first we are moving on to what? First, simple union. All right, so simple union, the first point you need to take for the simple union is you need to consider all the individual elements. All right, all the individual elements you need to consider. First point is, after considering all the individual elements, and next you need to consider the next point, P of I. What is P of I, ma? parent node. Alright, you need to consider the parent node of I. The I value you need to consider the next step. First, you need to make all the elements as individual, and next is what you need to consider the parent node as I. And next, third one, you need to initialize P of I2 minus 1 for root node. Means what we are going to present the root node, parent node, you need to keep in the table format as what? Minus 1. This is a third point. Alright. After making individual, you are keeping as a parent node, and that parent node, if it is a root node, you need to assign as what? Minus 1. And next, fourth one. And you need to perform the simple union. You need to perform what? Simple union for every element. You need to operate and perform simple union for each and every element. Union operation, that you need to combine the two elements and you need to make it as a tree structure. Now, fifth point, you need to update P of I after each and every element. So these are the 5 steps that you are going to follow for the next procedure for the simple union. Alright, all this will becomes under what? Simple union. So simple union, first is individual, you are making as a parent node of I, and if it is a parent node, you are initializing minus 1 in the table as a root node, and next one, you are operating, the next procedure is what? The union operation, and next you are updating the P of I value. So these are all the 5 steps. So what you need to have an algorithm? So we have a simple algorithm, that is union of I comma j and P of j equals to I. This is a simple algorithm. So what we are finding out? We are making of the union ith and the jth row, and you are making as P of j is what? I value, the parent of j, that we are going to give for what? I, and next you are closing the braces. This is a simple algorithm for the union operation. Alright, now we need to frame off the table, and you need to frame off the elements. So we need to take it as an example of what example? The simple union example. All these points you need to consider, and which one you need to make it as minus 1, and how you need to update the elements. All that we need to check it out. So we are going out the example for elements 1, 2, 3, 4, 5, 6. Alright, these are all called as what? Elements. Alright, first, what is the first point? Each and every element you need to make it as individual. So each and every element we make it as what? Individual. And now next what you are going to do? You are going to do the parent node for each and every step. Alright, the union find out. So union kavali ante you are taking as the first element as a parent node, and the next node you are taking as a child node. Union means these two that you are going to frame. Union of 1 comma 2. So what you are going to get? The parent node 1 you need to keep it as a parent, and 2 you have to give the upward direction. The 2 is gives as what? Child. Alright, these union operations that we have framed out, and you are going to give all the individuals as edit simultaneously. You need to maintain the table. Alright, what is the table? That we'll check it out now here. I, how many elements we have? 4, 5, 6 elements we have. Alright, now we have maintained P of I. Each and every element we have maintained for the first procedure. So that's why you need to make it as what? All minus 1s. Why? Because each and every element is the root node. So that's why P of I is maintained as what? Minus 1. And then we have done the operation of union. Two operations. The first element will be the parent node, and the next element will be your child node. So again you make these two operations. Union of 3 comma 4, and next union of 5 comma 6. So 3 will be your parent and 4 will be your child. 5 will be your parent and 6 will be your child. So this is the process how you need to go. After taking off all that, now here we need to check it off, P off. First, which union we are taking off? First union and third union and fifth union. So whatever we are having here, the parent node, that you need to keep it as -1, and next child you need to keep it as their parent node. All right, you need to update the value as what? The parent node. So what you're going to get the answer for 1 -1. Why? Because the 1 is a parent node. And next 2 key, what is a parent node? 1. 2 key parent node will be the 1, and 3 is your parent node. Again you need to keep what? -1. And next 4 parent node is what? Child. All right, next 5 is your parent node, and 6 parent node is what? 5. So this is the next table. First one completed, second one completed. This is for first union, third unit and fifth union. All right. Now we are making as a union of 1 and 3, these two. All right. So union of 1 and 3. So you need to make the tree structure here. So at a time we are doing here the union process, and we need to check the 1 and 3 union. For 1, you are going to get the union of what? 1. All right, this is the tree structure that we already did for the second step. Now we are taking of what? Union 1, 3. So 1 and 2 will be your child node, and you are going to add 3 to what? The parent node to 1, and 4 you will be your this. This is the tree structure for union 1 and 3. Now what is the parent node again? 1 -1. All right, why? Because this is a parent node, and next 2 parent node is what? 1, and next 3 parent node is not 1. Now it has been changed. All right, so the 3 parent node will be what? 1, and next 4 parent node will be 3. We didn't yet combine the 5 and 6, so as usual points that we need to have, that is what? -1, 5. All right, and next we are moving on to the combination of 1, 3 and 5. Union of 1, 5. P of 1, 5. All right, all this like. Now I am combining with 5 and 6. All right, so 3, 4 already there. This is 1 and 3 already structure is there. This one structure this, and now you need to add with 5 and 6. The 5 is again added to what? This, and 6 is added to here. This is the overall tree structure. The final answer. Now the final answer you need to update here. 1 is your parent node -1, and 2 parent node is 1, 3 parent node is 1, 4 parent node is 3, and 5 parent node is 1, and 6 parent node is 5. So this is your final answer for simple union. All right, clear? Yes. Simple. First elements will be individual. That's why we have given all -1s. And next we have combined the 2 union elements. 2 elements we have combined, and we make it as union. And the first element will be the parent, and second element will be your subtree. And we have to continue all that. And again, you need to make the last, whatever the parent node will be updated, you need to update here. This is called as the table and the structure of this tree. Clear? Yes. Now we are moving on to the next one, simple find. So simple union we have taken out, that is union of I comma j, and p of j equals to I. So that we have already seen there. Now what we need to check it out is simple find. As the name implies that with the finding is very simple. All right. So we need to find the element by taking the algorithmic steps. So what algorithmic steps we have for that finding, you need to check here. All right. So now we are moving on to what, ma? Second process, simple find. So we need to return the root element. So we need to return from the down part toward the upside part. The parent node key you need to return. So from where you will start, how you need to find out, all that will be same in the algorithmic steps. Algorithmic steps where the algorithm is going to find out find of I. So you are going to finding out. So that's why we need to keep the find and open the braces while P of I is greater than 0. If P of I is greater than 0, I equals to P of I. Close the braces, return I. So this is a simple find algorithm. So what is that? Find of I while P of I, this is important point. P of I will be greater than 0 means then it will moves to what? I equals to P of I, then return element otherwise. Alright. So this comes under the simple find operation. So the same algorithm will, the same tree structure will take, that is simple union 3, 4, we have considered the 5, 6. So this is the last simple union example only we are taking. So how you are going to finding out the parent root node is -1. The parent root node will be always -1 as we know that from the previous table we need to check the values. Alright. So how you are going to check the values, that is I equals to 4. For example, from the fourth element you need to get the value of root element is 1. Alright, whether we are framing that particular element 1 or not, we need to check here. So when we are starting with I equals to 4, find I equals to 4. So I equals to 4 that we have find. Now P of I is greater than or 0. Now what ma? P of 4 is greater than 0. P of 4 is greater than 0. That is I equals to P of I. Means what is the value of 4 we have there? P of 3. P of 4 equals to, what is the value from the previous table we have checked out? 3. Alright. So that 3 is okay. Now the 3 is what? Greater than 0. Again you need to iterate that process. Alright. Now I will becomes 3. Now P of 3 equals to 1. What is the P of 3 value? 3 root, what is that? We have 1. Alright, 4 root is 3, we have parent node, and 3 root is 1 parent node. Alright, 1 is greater than 0? Yes. So I equals to P of 3. What is the value? That is 1. Alright, next iteration. Again, we need to check. Now, I equals to value will be 1. Now, P of 1. So, what is P of 1 value? -1. -1 is what? Less than 0. Why value -1? This is a parent node. So, that's why the value is what? -1. -1 is what? Less than 0. Alright. Now, what you are going to return? Return I. So, what is the value you have here? 1. So, like that you need to find out the reverse step process by taking up the simple algorithm. So, this comes under the find operation. Clear? Yes. Now, we are moving on to the weighted union. So, again we checked out with what? First, we have completed the simple union and next we have completed the simple find by taking off the simple algorithms with the same tree structure and from the table itself. And next we are moving on to the weighted union. As the name implies that the weighted union, again we will take the two elements. But here some process will be there. What is that particular process? You need to check it out by checking out the algorithm. Here the weighted union, we are going to take the concept is that, for example, yes one. Now we are checking the concept called as the third one. Weighted union. Yes one, we have the 4 elements 1 comma 2 comma 3 comma 4, and yes 2 we have the 3 elements 5 comma 6 comma 7. These are all the disjoint sets. Alright, now S1 intersection S2 equals to pi. Why? Because we don't have any common elements over here, so that's why. So you have a concept called as here S1 union S2 means if number of elements in S1 is greater than S2. Alright, if number of elements in S1 is greater than S2, then S1 will become as parent and S2 will become as child. Clear? S1, if number of elements in S1 greater than S2 means S1 will become as a parent and S2 will become as what? Child. Alright. Then else S2 will become as parent and S1 will become as child. This is a process. By this process, we need to continue the next step. So, for example, here we need to check it out S1 union S2. Alright, we are checking off what ma? S1 union S2. How many elements we have in the S1? 4 elements and S2 3 elements. So the 4 elements S1 is what? Right? Greater than. 4 is greater than 3. So that's why S1 will become as parent and S2 will become as what? Ma? Child. Alright. In that now you are making as the first element. First element you need to make it as a parent. 2. For 3 also 1 is the parent and 4. Alright. This is the process. Marri S2. Which one will be the parent? 5 will be the parent. And 6 and 7. 6 and 7 we have taken out. Alright. So now this is 3 elements, this is 4 elements and you need to combine the element. Why? Because we have to checking of what? S1 union S2. When we make this S1 union S2, you are going to get 2, 3, 4 and again 5 is added to here, 6, 7. So this is S1 union S2. So 3 parts that we have divided. One is S1, S2, S1 union S2. Alright. So this is how we have divided. And here we have an algorithm. So what is that algorithm? Weighted union of I comma j. Weighted union of I comma j algorithm we are taking off. Alright. And P of I equals to minus count of I. P of j equals to minus count of j. Alright. So this is the first point that we need to check. First, we need to check minus count of I and minus count of j as these are the predefined algorithms. Now you need to make it of the temp. Both you need to add. Temp equals to P of I plus P of j. If, again, whatever we have discussed here, we are writing in the algorithm. If P of I is less than P of j, then open the braces. P of j equals to I, P of I equals to temp. We need to frame it out here. Else, reverse you need to write P of I equals to j and P of j equals to temp and close the braces. Alright, this is how the short algorithm that we have discussed. 1, 2, 3, 4, 5, 6, 7. Yes, one intersection S2 we have did and weighted of ij. You need to count first P of I how much and just you need to count that elements and you need to place here that. Here also place. Then you need to add that P of I and P of j. Then you need to continue the procedure. Alright. So what is that? What is P of I that we have? Alright. So S1 table we need to maintain. How many elements we have in the S1? 1, 2, 3, 4 and you need to take it off what? I. And next element how we have? I. 5, 6, 7 we have. And next union table also you need to take. I. 1, 2, 3, 4, 5, 6, 7. Now we'll check all the elements here. Alright, this comes under the parent node P of I, P of I, P of I. Alright, first we have a P of I equals to minus count of I. How many elements we have here? 4 elements. But we need to keep minus over here. And next P of j equals to count. What we need to write? Minus 3 elements. Minus 4, minus 3 elements. We have taken separate boxes. We have taken out the algorithm there. Then we have to frame now temp. So what is temp? Minus 4 plus minus 3. That is what, ma? Minus 7 is your answer. Now, what difference between the simple union and weighted union is that weighted union you will be making as a temporary value minus 7. But simple union you have the root node as what? Minus 1. So you can take it as here the weighted union means minus 7 as a root node. Alright. So like that you need to check it out. So you need to make it as by checking out the equation. So what we have in the previous for root 2, 3, 4, everything is what? 1. For 5, 6 and 7, 5. Alright, so what is the answer for this? 1 root minus 4 elements. The number of count elements we need to write for union 1 minus 4. And next, 2 parent is 1, 3 parent is 1, 4 parent is 1. Now, 5 root is what? Minus 3. Alright, why? Because the count you need to write, count of that particular element. And 6 parent element is 5 and next parent element is 5. Alright, this is the answer. Now next you need to update here. What you need to update? Minus 7 here. Why? Because this is S1 union S2. So minus 4 plus minus 3 is what? 1, 1, 1. Alright. Again 5 union. What is the union we have? See, 5 also gives to what? 1. So that's why here you have 1. And next is 5, next is 5. This is your table for S1, S2, S1 union, S2. And that is your algorithm. Clear all of you? Now we are framing as a collapsing find. So the collapsing find is a concept where you need to take it out 10. Collapsing find, the last and final word. 20, 30, 40, 50, 60, 70. So this is what the diagram for the collapsing find. As the name implies it, collapse find. So when we are taking out all the different types of comparisons, see, when we want to take to move on to the parent node, the comparisons will take here from 70 to 10 is like 70 to 60 is 1 comparison, 2 comparison, 3 comparisons. 3 comparisons we are going to take. So we need to reduce this. All right. We need to reduce the time complexity. So that's why we need to make direct connections from the 70 to 10 and 60 to 10 and 50 to 10 like that. All right. So where we can reduce the time complexity and the comparisons part is also will be reduced. So to reduce that, the collapsing find will be the excellent method to find out this collapsing find. All right. The same procedure you need to check out. So for you, if the root node is going to take it as find of 70, what is the root node we have, ma? 10. Next, find of 40. Find of 40 is also root is 10. Next, find of 50. What is the find of 50? Root 10. So we need to take all the roots that is 10, but in the different variations, if you are taking the comparisons is also like same. So 40 to 30, this different, this 2 comparisons. So the comparisons, whatever we are taking, you need to check it out. We can use here the 2 combinations. All right. So when we are finding out with 1 combination, we need to take it out as algorithm steps. So what is the main algorithm that you need to have is that collapsing find of I, open the braces, root I. All right, open the braces, root I, while P root is greater than 0. All right, then root equals to P of root. While root I not equals to I, where root I not equals to I, open the braces, S equals to P of I. Then P of I equals to root I equals to S. Close the braces, return root, close the braces. This is the algorithm. First you need to find of I, then root of I. Same procedure where we are used in the simple find operation. Here the finding operation is also the same. But while p of a root is greater than 0 and root equals to p of a root, and while root not equals to I, s equals to p of I equals to root, I equals to s. Alright, now we'll check it out with a simple example. The first one, root I we have taken. Root I is not equals to I. So first I value is 70 that we have taken. Now 10 not equals to 70. Yes. 10 root is not equals to 70. That is yes. Then yes equals to p of 70 equals to 60. Same algorithm what we have taken, that p of root 70 that we have taken I value. That value is what? 60. And now p of 70 equals to 10. So I equals to 60. This is the first procedure completed, the main 3 steps. Next, not equals to we need to find. Root not equals to I, where 10 not equals to 60? Yes. Again, we need to go of what? Yes, p of 60. What is p of 60 value? In the table, take it out. 50. Alright, now p of 60 equals to 10. Now I equals to yes, yes equals to 50. This is also we have find it out. Alright, so the stable structure what we have taken out. So all this continuous process and that main diagram will becomes. Alright. This main diagram is going to get for you with the different options 20, 30, 40. But here we have taken out in the different format. First 50 will be collapsed, next 60 will be collapsed, next 70 will be collapsed. So this is how the collapsing find window is going to be take it out. So I have did for 50, then you do for 60 and 70, and at last you are going to get the diagram all with less comparisons. All right. Now one comparison only, one comparison only, one comparison only. But here it takes like 3 comparisons. So every comparison it going to be reduced. All right. So almost all like 15 comparisons that we have taken out will be reduced to 12 comparisons. All right. When all the process is completed. This is called as a collapsing find. Thank you. We'll see you in the next class.